Every second, a silent snowfall drifts through the ocean. No, not ice, but marine snow. This isn't the kind of snow you catch on your tongue. It's a dense mix of plankton corpses, animal waste, mucus, and dust, all clumping together and sinking into the abyss. It might not sound glamorous, but this strange, sticky snowfall plays a massive role in Earth's carbon cycle. It helps regulate the planet's climate, acting as a natural conveyor belt that traps and stores carbon deep in the ocean. But here's the real mystery: what's hiding inside this marine snow? How does mucus shape its journey? And why does it matter for the future of our climate? Let's dive in. Marine snow is basically the ocean's version of compost. It's made of dead plankton, fish poop, dust and organic particles, and mucus, lots of mucus. All these tiny pieces stick together, forming soft, flaky aggregates. Some float for days or even weeks before becoming heavy enough to sink. And here's where things get interesting: marine snow locks away carbon as it sinks. The deeper it goes, the more carbon is stored in the deep ocean for centuries, or even millennia. This process is called the biological carbon pump, and it's one of the most powerful ways the ocean regulates Earth's CO2 levels. But there's a twist: marine snow doesn't just fall passively. It's an entire living ecosystem teeming with microscopic life. And those tiny inhabitants control what happens to the carbon inside it. If you could shrink down and enter a piece of marine snow, you'd find a bustling microbial metropolis. Bacteria colonize these sinking particles, breaking down organic matter. Tiny zooplankton nibble at it as it drifts down. Some microbes even release carbon back into the ocean, reversing the process. The key question: how much carbon actually reaches the deep sea, and how much gets re-released into the atmosphere? The answer largely depends on something unexpected: mucus. It turns out that many marine organisms, especially plankton, corals, and jellyfish, secrete sticky mucus that helps marine snow form. This mucus is like nature's glue, binding particles together and making them sink faster. Faster sinking equals more carbon stored in the deep ocean. But there's a problem. Some bacteria break down this mucus, turning it back into CO2 before it can reach the seafloor. The balance between sticky sinking mucus and hungry microbes determines how much carbon gets locked away, and how much escapes back into the atmosphere. And this balance is shifting. Here's where things get serious. As ocean temperatures rise, bacteria and microbes become more active, breaking down marine snow faster than before. That means more carbon is released back into the water instead of sinking into the deep sea. Less sinking marine snow equals more CO2 in the atmosphere equals faster global warming. On top of that, pollution, like microplastics, can alter how marine snow forms, making it less effective at trapping carbon. Scientists are racing to understand how these changes will impact our climate. And some are asking a bold question: can we engineer marine snow to fight climate change? Some researchers believe we might be able to enhance marine snow to absorb more CO2. Ideas include boosting plankton blooms to create more organic material for marine snow, altering the mucus composition to make particles sink faster, and adding biodegradable particles to encourage carbon storage. But playing with nature always comes with risks. Changing marine ecosystems could backfire in ways we don't fully understand. For now, the best way to protect marine snow's carbon-storing ability is to reduce ocean pollution and slow climate change, before this natural carbon pump starts to break down. Marine snow might seem like just drifting debris, but it's actually one of Earth's most important climate regulators. It quietly removes carbon from our atmosphere, keeping temperatures in check. But as climate change accelerates, this fragile system is at risk. So, what do you think? Could marine snow be Earth's hidden climate hero, or are we underestimating the danger of disrupting this delicate process? Let's talk in the comments. If you loved this deep dive into the hidden world of marine snow, don't forget to like this video if you learned something new, subscribe for more mind-blowing science, and hit the bell icon so you never miss an upload. Thanks for watching, see you next time.